Okay, here are a couple problems where we need to write an algebraic equivalent for the given expression. So we're going to look at this first one right here. We'll call that number 1. Cosine of 2 arctangent of x. So this is utilizing our inverse trig functions. So if I go back and I think about what arctangent of x is just another way to say theta. So really what this expression says is it says, what's the value of the cosine of 2 theta? Now it's got to be a little bit more detailed than that though, because it's more than just the cosine of 2 theta. What is the cosine of 2 theta? Well, I'm going to go back to my knowledge of inverse trig functions. Just this guy right here, arctangent of x. Okay, arctangent of x. So arctangent of x, tangent is opposite over adjacent. So the opposite side from theta would be x, and the adjacent side would be 1, x over 1. And from here, I can find the hypotenuse of this triangle by using Pythagorean's theorem, and I get the square root of x squared plus 1. Square root of x squared plus 1 is the hypotenuse. Now, taking into account that I've got the cosine of 2 theta, what is the cosine of 2 theta? Well, we know the cosine of 2 theta to be cosine squared of theta minus sine squared of theta. And look at that. Theta is right here. So the cosine of theta is going to be the adjacent side. Here, I'm going to color code this for us. The cosine of theta, okay, is going to be 1 over the square root of x squared plus 1. Adjacent over hypotenuse. So if the cosine is 1 over the square root of x squared plus 1, cosine squared would be that value, that ratio squared. And then we have minus, and then sine squared. Yeah, I'm going to make that a little bit thicker. Sine squared of theta. Well, the sine of theta is the opposite over the hypotenuse. Opposite over the hypotenuse. And then that value is squared. And now we just simplify. It's as easy as that. I've got 1 over x squared plus 1 minus x squared over x squared plus 1. That's going to give us 1 minus x squared all over x squared plus 1. Nothing simplifies. It is what it is, and that's our answer. So what is the cosine of 2 arctangent of x? It's the cosine of 2 theta. We're going to use arctangent of x to draw a triangle, with theta being the reference angle. Our ratio is x over 1, x over 1. The cosine of 2 theta is a double angle formula that's going to allow us to utilize this triangle in which we have an angle theta, 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 and then input those ratios or substitute those ratios in for our trig functions, and then combine the two fractions and get our final answer. So let's do this again. Now that we know, and you can press pause and you can try this for yourself. Now that we know, and I think it's, I think this one's not arctangent, I think this one was arcsine. Let me fix this one. I'm almost positive, and if not, arc cosine. I'm pretty sure it was arc cosine. If not, then, you know, I'm doing one that is different, and that's okay. So we've got sine of 2 arc cosine of 3 over x. So this inverse trig function right here is just another way to say theta. So really what I've got here is the sine of 2 theta. The sine of 2 theta. So I'm going to utilize the inverse trig function, arc cosine, adjacent over hypotenuse. And then that's going to give me x squared minus 9 underneath the radical for the opposite side. Yep, x squared minus 9, agree. Okay, so now the sine of 2 theta, that formula is just 2 times the sine of theta times the cosine of theta. So in place of sine of theta, we'll use colors here again. In place of sine of theta, I'm going to have x squared minus 9 over x. So the square root of x squared minus 9, square root of x squared minus 9 over x. And then the adjacent, let's do that in green here. The adjacent over the hypotenuse would be 3 over x. And then we just multiply straight across. So I would have 2 times 3 times the square root of x squared minus 9 all over x squared. So that's going to be 6 times the square root of x squared minus 9 all over x squared. And this looks a little strange to me, so I'm going to make sure that I've done this right. Let's see, I've got arc cosine of 3 over x. So that's going to be the adjacent side over the hypotenuse. And then the opposite side would be c squared minus a squared, all under the radical. C squared minus a squared under the radical, so that works. And then the sine of 2 theta is 2 sine of theta cosine of theta. So here's my 2. And then the sine of theta, opposite over hypotenuse. And the cosine of theta is adjacent over hypotenuse. And that gives me 2 times 3 is 6 times the square root of x squared minus 9 over x squared. So I believe that that's correct. I think we've got it right.